Okay, tutorial 1B. We will look at problem number 2. Problem number 1 is simple, so I am just switching to problem number 2. Problem number 2 is very interesting. It is about a lawn roller, okay, whether to push a lawn roller or pull a lawn roller. They have just given a drawing of this sort. So, let us say this is the roller and there is a small obstacle, let us say the handle, and it is being pushed with a force F, let us say, and this is about 900 Newton weight, and this height is given as 75 mm, which it has to overcome. So, if he pushes, it has to overcome and go over. Okay. The question is whether pushing like this is more convenient or pulling like this is more convenient. That is the question. Okay, the radius and all those are given. You already have it in your tutorial sheet. How do I go about? The first magic is always drawing the free body diagram. Okay, that reveals quite a few things, quite a lot of information related to the decision that we have to make, whether to push it or to pull it. Okay, in this particular case, so let us draw the free body diagram. Okay, there is a force acting towards the center of this equal to F, right. Let us assume that the force is passing like this, either it has to pass through before this point of contact or beyond this point of contact. Okay. You will easily realize that it has to be beyond this point of contact for this to roll over. Okay. So, some angle is given. So, deliberately I will just draw it like this, so that you can visualize it to be rolling over. Okay. What is the force that is necessary to push it? That is the question. So, this is 900 Newton given. As usual, we need to find out what are the points of contact with this particular body, because the body in question is the lawn roller, right. There are 2 points of contact, as you can see. There is one point of contact here, there is another point of contact here. Okay. So, let me just remove this point of contact, this is over which it is going to roll. Okay. So, the possible resistance to motion would be perpendicular to this, and there could also be some friction. Okay. So, let us call this as N, let us call this point as A and this as B, this is let us say N A, normal at A, and let us say this is friction at A. Let us examine point B. Point B is also a contact, but for it to roll over, it has to lose contact from here, so that it rotates and rolls over, or in other words, we are looking at a situation where it is just losing the contact at B, which means that there is no interaction taking place with the ground, and therefore, this is the only diagram that I will be looking at. Okay. Now, it is very simple now. If I have to find out what would be the force that relates to this particular thing, I just have to take moment about this point A, okay, which will involve a 900 Newton a moment that is caused by this 900 Newton in the clockwise direction, right, and a moment due to this force that causes an I am sorry 900 Newton which is in the anti-clockwise direction, and F which is in the clockwise direction. Clockwise direction has to just match the anti-clockwise direction for this to just happen, right. In contrast to this, the other one, though looks simple, looks similar. When you draw the free body, let us say this is the force F, there is this angle that is given, there is this 900 Newton, rest all are the same. At this point, which is point A, we again have the normal reaction. So, let us call this NA, and this is FA. You may be wondering why I am drawing in this particular direction. It does not really matter, because we are looking at a situation where it is a static friction. Okay. Also, if I take moment about this point, whatever be these two forces, they will not take part in the moment equilibrium equation. Okay. In this particular case, as you can see, this is the arm of this force, and the other arm, which is to do with 900 Newton, remains the same. Okay. So, as long as this arm is bigger than this arm, we can categorize that this will need less force compared to this. You will also find out while calculating that the force needed for this happens to be, let me just see what we have worked out. This happens to be 1866 newtons that has to be applied in order to start the rolling process. In this particular case, this happens to be just 607 Newton. So, as you can see, pulling is a much better process of rolling it over.